Okay, hola and welcome. Kudos to Titilon or whatever for the music. My audio is working. Let's go. So, the first thing I'm going to show you is this code. So you can see, can I make this bigger? I don't know how. There's some way. Anyway, you can read it. Let's get this test running. This is a script, and I'm just gonna run it in the background to see how long it takes. So you can see the relative time. The thing's gonna be chugging along at the bottom. Right now, it's doing this first step. It's copied the DEM to the output file. So you run kp, starting TPI calculation process. And so what it's doing is it's downsampling by a factor of 5 times. And each time, it's also computing the gdal TPM. Or TPI. Sorry, I'm going to get my acronyms wrong a lot. So you can see now it's calculating test for D1. This is a downsample of 1, aka just copying the image again. So it's kind of a redundant process, but after it finishes doing this, it's going to compute the TPI. So it's a little bit of a lazy way because I just reuse the command with 1 instead of having some downsample factor. So it just copies the image and then does the TPI process of it, calculating TPI. And this is the slowest one, so you can see that's how long it took for no resolution. Now it's calculating the normal, or normalizing it. It also takes, it's a big 300 megabyte file, and I'm surprised it's going this fast. And I think this is pretty much it. Okay, so now we're actually computing the one that is actually hard-coded in the bottom here. So right now we're doing this, and are we gonna actually, hopefully this works. I want to see if the topo works. So now, test the, I guess maybe it's doing this twice. Oops. Bash it down some. I don't need this a second time. It's redundant, so I did that twice. So you can see this is actually the slow process. So all that time it even did at full resolution twice. It made all of these files. I'll open a new terminal here and go to ls cd test 4 ls-sh. So you can see these are the main files that I made. It actually did this work twice. And you can see this is a 400 megabyte TIFF. But then as soon as we go down 4x downsample, we have a 24 megabyte TIFF. So this is downsampled by 1 in TPI. So theoretically, I can stick this on Cloudflare for free. You know what I mean? That's pretty sick. We also have this downsample again, so this is a normalized version, the downsampled only, so downsampled DEM, downsampled TPI normalized 1 sigma, and downsampled TPI before normalization. We also have the same thing for like D444, and you see this is only 8 kilobytes. For 2 times, we only have 1.5 megabytes. So showing this image to someone on the web is like now feasible if we do this forward or downsample and then show the TPI, and it has almost the same data. I'll show you that in a little bit. But we'll go back. This is still running. Okay, so that finished. And now we're gonna do all of these 4 things. So we'll wanna go, I'll just enter to continue, and I was gonna run all of those. So you can see this is how fast this first one is going. So it's doing it on only the 4 downsamples, so 24 megabyte file. it loaded it into memory, and now it's doing the scale of 20, which I guess is 5 times 3. I don't know. I don't know how it gets this 20 number from. But it should be running this first one where it's going 1, 5 for 3. So yeah, maximum scale 5, minimum scale 0. So it's 1 plus 5 plus 5, or 1 plus 5 plus 5 plus 5, I don't know. Now it's doing 12. Maybe, yeah, like this is weird. I don't know how exactly it's getting this number. If someone knows, let me know. But it's just running Saga TPI with a min of 1, a max of 5, and 3 iterations. And one thing to notice is sometimes this like runs out of the doubling heap size or whatever. I don't know how to fix it, but it doesn't seem to make any errors. It still generates a TIFF. I don't know. Maybe we can do anything. So you can see that's how long it took to. It took 1 minute and 23 seconds to do that first one, and now we're operating this on a D16 image. So this is downsampled 4 times and another 4 times. So 4 times 4 is 16, I guess. And you can see it's going faster, but scale 5. I guess this is a scale in actual meters, and this is coming from the calculation of the pixel size and this like kernel size. That would make the most sense if I'm being 100% honest. So what that means is that this is doing the scale of 500 meter hills, essentially. Which I guess would be like 16, so 16 meters times 32 is maybe, I don't know, 512? And it's doing 8 scale, so it's going down, 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 down. This is where I don't know if we need so many. We might not need 8 scales, we might only need like 4, but we'll see how this image looks. This is all, like, these are all experimental images that I'm just trying out. But you can see because, like, each one of these is going through the entire image at, like, quite a large pixel scale. It's still doing a decent amount of work. It's taking some time to do this. And you have to remember this is already downsampled twice. So it's like only 1 megabyte image, and this is still how long the process is taking when you use values like 432.8. We can probably get away with like 432.3, and it'll be good enough, or 432.4. But I'll let this keep going in the background. Maybe while this is going, let's see if I can make this not full screen so you can see. I'll show you some payoff. This is from the previous experiment, so it's actually the same raster, so it's basically same data. So this is from running it at 210.4, 210.4 on the smaller resolution, and on the high resolution 832.4. So you can see this very high resolution one is actually very nice. It like gets some big regions. Sorry, where was I? Yeah, so it's 4 times downsampled. This is like normal TPI with the downsampled with no smoothing or anything for I guess 64 times. So this one is a little bit less, but you can see how much smoother it is. It's still a little bit chompy when you move in. Like these are like 16 meter blocks. And then we also have the very fine detailed one that gets these small hills, but it's almost like not so useful having the very fine detail. It's probably more worth it to go directly to this level for rendering for lots of people. But this really isn't so bad. So for 24 megabytes, you could give them this quality of result. With like, it even has the detailed mounds here. And really what I'd do is I'd make it so that these layers are turnable on and off. But it's kind of good to have them both on. It might be good to have like a lighter color for the broader things, a little bit more opacity. I don't know what I'm talking about. So you can see this finished. The other ones went very fast. It went from like taking minutes to, once you're operating on a 1, 2, 3, so 64 time reduced image, it only takes 24 seconds to do that big processing. So the next thing I'll show you is what you do after you've generated these pictures. So we're in test 3, let's go into test 4. Let's make, let's just be at the top here. So the first thing I want to check out is, let's check out that smallest one, so D44, 432.8. So this took a couple minutes, but let's see, it might be a fairly good one. And so whenever I open one of these up, I have to go style, and I have style saved, so I go load style. One thing I really want to do is automate this so I don't have to like select the style. I can like set a default. I'm sure there's a way. The set default doesn't work, it seems. Anyway, apply, okay. So you can see this is a fairly good TPI. It's showing like these regions here. And the red and the blue, like all of these valleys are showing as valleys, and this ridge is showing as a ridge. Especially up here where there's actually the real mountain here. If we turn on, I'll just show in this video. This is the actual DEM. So without any data, this is the raw 1 meter DEM of the area. You can see this red is the high regions, and then on top of that I'll put our overlay, and you can see it's highlighting the hills. So really the end product would be something like that. Ooh, the other thing let's check out is that it makes the topo lines. Where's my shape file? I don't know if it actually made this shape file. Do I have the command here? I guess maybe it made it in this folder if I was to. Topolines.sh. Okay, I just have a typo in my script. This is actually called topo lines. So the problem is now I have to know what these variables are. But I think I have D4 path saved already, so I think I can just run. Let's just run the 10 meter one only. And I'm just going to change this name to test 4. And I'll change this to D4 path is probably okay. Sorry, I shouldn't be debugging on the fly. Let's just get rid of this check for now. Who needs tests? Sorry, topo lines. Does it actually work? I guess it's because I have added the third thing. So anyway, it's generated the contour line, so you can see how long that takes. About that long for the downsampled version at least. And now test for topo shape. So this is kind of nice. You can see I've added the contour lines. These are on the downsampled version, but it's probably good. I have changed it from 5 meters to 10 meters. The 5 meters was actually, but I guess you can see where the holes and the peaks are. So yeah, this would be something like what you would be able to display. You would have to host the actual satellite imagery somewhere else. Like this, this file can't be hosted online, but we could host this information. ls-sh. So this topo line shapefile is still too big. We have to do maybe it on the even more. Like this is a 38 megabyte shapefile. So I guess if you do topo lines 25. Oops, I shouldn't have overridden it. But okay, now it's less than 10 megabytes. Let's do some bright green. The other thing we can do is topo 10, but we can do it on D4. And then we can do topo 10. Let's see how this. Sorry, I'm not talking so much, but so that went way faster. And we can see how this looks. So this is actually doing the topo lines based off of the kind of downsample data. So it's a little bit blocky, but it's also a little bit good. You can see the data that's actually going off of if we do DEM D44. So this is what I made the topo lines based off of. So I downsampled it first and then made these topo lines. So you can see how this generation kind of took place. But I'm guessing you may also want to do one round of smoothing before you generate the topo lines. That way we don't get so many like little holes. But these little details actually are nice, you know what I mean? It's nice to know that there's like one peak, and a little valley here. Maybe we can pick our way up. Of course, basing topo lines on like the even more fine-grained data might produce nicer results, but maybe this is good enough, especially if it's automated and free or something like that. So for example, we could do test T4 DEM this topo lines. So let's make a sample package. I would also include this D4, D4, D4. So this is D4, D4, D4. Pretty good. Or this is double D4. Have we looked at the this one? I guess we have it. This one. Okay, but we haven't styled it yet. Style, load style. I really want to automate this. No, I don't want to. So yeah, this one's nice. Let's create one group. And then we also want the D4, 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 2, 5. I guess, yeah, this one. One, two, three. Okay, so now what we have here in this group, where are my topper lines? Let's put them at the top. So we have topper lines. I'll leave this off for the test. We have the normal DEMs. So this is the high resolution and lower resolution if we zoom in. So this is, I guess, 4 meter and 16 meter DEM, 4 meter, 16 meter. There is 1 meter, but that's too much data to host or for people to download all the time. Yeah, or basically, this is 25 megabytes. This is 1 megabyte. This one is 25 megabytes. So this is the detailed hill, so a small scale hill, so you can see there's a small hill here, etc. Also 25 megabytes, and then these ones are like 1 megabyte and less than 1 megabyte, and then this is a couple megabytes. So all in all, we're looking at about 75 megabytes per tile. Plus the original DEM would be like 300 to 400 megabytes, so half a gigabyte per tile of storage space, and you need another half gigabyte for all the processing. You have to copy it. You more need like a whole gigabyte for the processing space. The way I'm doing it, at least. So, yeah, I'll stop rambling and just let you take in this beautiful package. The one thing we're not doing is we're not doing actual like peak detection. But I'm guessing something like this red layer is what you would use to walk up the slope. Really, you should be able to find like one ring, and then you can go to all of the rings inside. Like walk up the rings of the topo lines or something like that. That's probably a fairly effective way. And you just like have some thresholds. And I guess I'll end off this video. I'll show you the same thing styled fairly nicely. So this is just a 1 meter DEM styled with elevation. And then on top of that, this is a sample of the same process I've done. And then this is another sample doing it only with the gdal. So that fast thing before I ran any saga commands. I made a few things with this. Maybe we wouldn't want to put this larger scale features on, just because it's looking too blocky, but it is useful data. And we could even, but this level, this like 4 times is kind of needed at least. And you can see in here, this is the scales I was talking about. See, like that 4 times is like this 512 scale. And if we're not doing some further analysis where we take lots of pixels, then we need to do it on that level of data. Anyway, that's about it. ls-sh test 4. And so yeah, we can see that and cdu dot. So you can see this topo is only a couple kilobytes now, the way that I've done it. This test 4, the whole thing is 1.6 gigabytes. We've copied the original file 3 times, which is a bit unnecessary, but not really. It's the original image, the TPI version, and then the TPI version, or this is original, downsampled by 1. So yeah, there's only 1 extra copy really. But really we only need to keep this last version and maybe the original. So we could get rid of these 2. So that's probably the first thing to delete. And then you can see it's 23 megabytes, 1.5 megabytes, 96 kilobytes. So these files are fairly small and they actually are fairly informative. So like packaging these more detailed levels might offer some good value at a low cost for hosting at least. And you can see all of the metadata files that were generated. But that's about it for this video. Hopefully you like this work and you find it useful. Check out our blog post. I've put a blog post with this script, and I'll try and link to the GitHub there eventually. I'm not sure where I'll put the stuff. But for now, just look at the power of gdal and saga. Pretty cool stuff. So this is pure gdal. You can get some product like this. And then this is gdal with saga. You can get some product like this. And this is our new test, what we did, which is also gdal with saga, which I think is a fairly nice product. Yeah, we're looking for the light red areas. So the more pure red, the better, or something. I don't know. We also have topo lines. Like, I like this graph. I think this is a nice map. Anyway, that's about it for this one. Peace out, and you have a wonderful rest of your day.